Hey guys, we are here with IPFS. Molly is the IPFS project lead, and she'll be doing a talk around Defy Dapps on IPFS, and I'll let her take it from here.
Hello, everyone. Excited to chat with you all today. First, I'm going to give you guys a little intro to IPFS, since maybe not everyone here is familiar, and then we're going to dive deeper into actually how you build the front end for a Defy Dapp on IPFS.
So it seems the chat broke, so people can ask questions and interact via the Ask a Question section. And if you guys can just confirm that you can hear us, that'd be great. Thank you. Do you see where the questions are? Ask a question.
I do.
Okay, perfect. So you can get started. They confirmed.
Thank you, guys. Cool. So IPFS is designed to make the web work peer-to-peer. So it takes the internet, the web we know today, from a centralized HTTP model where many nodes all connect to a central server in order to get data, and instead allows a much more flexible orientation where nodes can connect directly to each other to exchange data. And it does this by using content addressing. So instead of addressing data by where it's located in the network or what entity is hosting it, like Facebook.com, instead it loads data based on what it is. It's a cryptographic hash, which let's take a reference to, say, baz.png, which, example.com here can constantly change and update what baz.png means, and you have no way of knowing if the data you're getting is the data you meant to get. Instead, it addresses data by its content address, which means you can always verify that the data that you're fetching is what you intended to grab. IPFS aims to address a ton of different problems. Some notable ones are censorship. So instead of having a single central entity that has the control over what data you're loading and can therefore be subject to authoritarian control, it enables many parties in the network to all maintain and host a service. It's more efficient. Instead of having to go to that central party, no matter whether you already have the data right next to you, or your neighbor has it, or cached on another device you own, you can be much more flexible about the model through which you get data, which can help be much more efficient in the distribution of content. And that resiliency also helps mitigate faults and errors in the network. So say if you're offline, you can still collaborate and use the tools and applications you care about. The Ipfs ecosystem is large and thriving across a ton of different verticals. This is just a small subset of the various applications that are building on top of IPFS in a number of different verticals. So you have content-oriented things, video, music, various other tools like that. You have more productivity or chat-based tools, identity, data, social media, marketplaces. A ton of different projects are building in the IPFS ecosystem and working together to share content and collaborate. Most recently, as of last Tuesday, we actually released a new version of IPFS 0.5, halfway there. And this is really exciting. A lot of big major improvements went in here, especially around performance and efficiency. And so I'm actually going to drop the link to that in the chat, which may or may not be working. But if it is, please do go check that out. There's some cool upgrades. If you're running IPFS, help us make the network better by upgrading quickly. And if you're not, it'd be a cool time to check out and see what's new. All right, so the meat of this talk, especially for this audience, is thinking about how IPFS is relevant to the DeFi space. So starting first, what is a DeFi Dapp? These are open source tools that help improve the current financial system by intermediating middlemen and centralized controllers using decentralization. They're a subset of dApps in general, which generally run on peer-to-peer networks of computers and avoid any sort of central service or sole controller or maintainer of the network. Main benefit is that you're no longer subject to that central party's control. So thinking specifically for a DeFi Dapp, two important properties that need to be met here. One, anyone can run a DeFi Dapp. It's permissionless. Any interested party can spin up a node and participate. And no single entity controls or operates the service, which means that you want a distributed network of peer nodes that are all responsible for hosting or approving transactions or helping make that service exist. So what is a DeFi Dapp? Really, there's two major components here. There's the static web app front end that can be hosted on something like IPFS and distributed over a peer-to-peer network, and a smart contract-based backend hosted on a blockchain like Ethereum. I'm going to spend most of my time talking about the static web app front end, since most of the other people at this conference are talking much more about the backend side of things. I'll focus specifically on the IPFS front end component. So tons of applications are already using IPFS for their DeFi distributed front ends. A small subset includes folks like Kyber.crypto, which put their front end up on IPFS, MyEtherWallet.crypto, Diffusion Dex, Blocktimer.dapstar.eth, Koinomi.crypto, and the many different variants of Uniswap Exchange that are all up on IPFS as static front ends that can be distributed fully peer-to-peer. So how does one actually go through deploying a Defy Dap front end on IPFS? So there's three major steps. First, you want to add your static web app front end to IPFS, and there's actually a lot of different tools that have come into the network even quite recently. A number of these are really only emerging in like the Q1 timeframe that allow you to very easily put up a static web app on IPFS. Next, you want to be able to load the DApp via some IPFS gateway, either an HTTP gateway or a local gateway that you run on your own node. And finally, you want to be able to point a decentralized domain towards your content to make it really easy for others to find and reference and access that information. So starting with the first one, adding your static web app to IPFS. Fleek is a new application that has come into the space. It's actually all built on IPFS as well, but it allows you to very, very easily get started deploying a static front-end to IPFS. You can connect it directly to kind of an existing GitHub repo. It works with things like Hugo and other general static site frameworks, and it's very seamless to just quickly get up and running. And with a few clicks of buttons, boom, you have your static web app deployed on IPFS. So definitely easiest, like 5 minutes and you're up in there if you already have all of the information in GitHub. So effectively replaces Netlify, but works on top of IPFS instead. Another example of a way to get up and running is to use Ipfs Desktop or the Ipfs Web UI. Once you have your own local node running, you can very easily add files and get that pinned to Ipfs so that anyone can find and access it. Two other examples that have come in recently, the ENS domain manager now lets you upload files and folders directly to IPFS, which you can then address with your ETH link, your ETH name. Similarly, .crypto Unstoppable Domains also allows you to do this, and they have built-in templates and drag and drop upload. So very easy to get started getting your static site on top of IPFS easily. Oh, gotcha. I can toggle my video off. Bigger, better, wonderful. All right, so presuming all of that, we have got our static web app added to IPFS using one of these easy tools. Now you want to actually load the data. So two main choices. You can either use the IPFS HTTP gateway, which there's a number of these about. You can check the public gateway checker, and this will tell you different information and ping time to all of these different gateways. Lots of different groups and institutions run them. An example is Cloudflare. I think as of end of 2018, they deployed a distributed web gateway for IPFS. And so you can load data from the IPFS network through one of those HTTP gateways. We also, the IPFS core team, runs an HTTP gateway, which is it's grown a good chunk just in the past 6 months. It's now getting 13 million requests a day, accessing about 5 terabytes of data. And so that's one major way for your website to bridge and gain access and adoption in the for users who are accessing it over the normal web today in Web 2. The other option is to actually load it over your local HTTP gateway. So if you're running a local IPFS node, say through something like Ipfs Desktop, which is a handy little tool that we built to make it really easy for folks to run and introspect onto a local IPFS node, this will directly on your local machine allow you to connect to other nodes in the IPFS network and fetch content that way. We've actually seen a lot of growth and proliferation there as well, about a 30x increase last year in the size of the public network. And we now have hundreds of thousands of nodes all participating and connecting with each other, which allows them to share data and fetch this data back and forth. All right, so now we've added our static front end to IPFS. We're able to load it via either an HTTP or local IPFS gateway. And now we want to actually point something that's semi-human readable or actually resolve the links to IPFS in kind of a decentralized way. So most notably and exciting, recently, about a month ago or so, Opera for Android added default built-in support for IPFS. So now you can directly reference IPFS : / or IPNS or other links directly in the Opera browser. So more to come in our upgrade path, but that's a awesome first step in terms of having really built-in support into the browsers that everyone is using that allows people to resolve in a decentralized way the content in Web3. We've also built a handy tool called Ipfs Companion, which is a great way for people to either directly load content from a local IPFS node that's running, or just translate to a gateway. And so it's a useful way to kind of bring more of that Web3 tooling to folks that are running in normal web browsers today, say Chrome or Firefox, or actually this is the Ipfs Companion extension is default embedded in Brave. So you can, with one click, enable the Ipfs Companion extension and then run even an embedded JS IPFS node. So it's possible to have an embedded JS node running entirely within your browser. Another awesome piece of tooling that we worked on with the Ethereum name service back, I guess last June, was this new tool called Ifdns, which is what enables you to do .eth.link URLs and load Ethereum sites without any special configuration. So say if you don't have MetaMask installed or you don't have Ipfs Companion, any user anywhere on the web can just append .link to any .eth TLD, and that allows you to load it seamlessly using DNS. And so that's, again, the sort of tooling that helps cross the chasm and bridge to folks who have not already come to the Web3 space and decided that they want to participate. And the importance of that tooling is that it extends the reach for all developers who are building in this space and makes it much more accessible for them to find the users that want to, say, browse their website or something along those lines. Another similar piece of tooling, the Unstoppable extension, it also has a ton of that functionality. It allows you to resolve to an HTTP gateway or a local gateway if you're running a local node. And it also does the resolution of like .crypto or .zil TLDs. All right, so now you've added your static web app to IPFS, you've loaded your DApp via the gateway, and you have a decentralized way to point domains to the content you care about. This is all part of an upgrade path. So when you think about the tooling that we're creating here and how we're working to enable the ecosystem, we need to bridge from all of the people who are coming, just like Web 2 worked with Web 0, Web 3 to make all of these applications accessible. We need to be working to bridge users from the read-write web into the read-write trust web. And that means building the tooling and the bridges that people can cross on and demonstrate that Web3 has a lot of services and applications that actually deliver them real benefit. And so all of the tooling that's being built here and the new UX that really reaches people's existing experience and desires for what the web should look like is really part of our upgrade path here. And something that as more people invest in it and building the nice UX or the infrastructure or the next layers of functionality, the easier it is for the entire space to grow and improve. So thank you so much. And I'm excited to take any of your questions. Hopefully this was a nice lightning tour of all of the ways you can build your DApp on IPFS. Someone was going to ask something about Brave.
All right, guys. So to ask questions, bottom left, ask a question. Do you want to just hop into a common question that you normally get around Brave? while we wait for people to ask questions?
Sure thing. Let me figure out how to toggle my video back on so people can see my face.
All right.
Cool. Common question about Brave. Probably first is like, how does it work? What do you do? How do I get my my local IPFS node working on Brave? And you kind of have two main options there. First things first, go to the extensions area of Brave. I think it's similar as in Chrome, // extensions. And from there, there's a one-click, enable IPFS toggle, and that will dynamically detect whether you're running a local node. And so if you're running something like Ipfs Desktop, then you will automatically be able to fetch, say, go to the ipfs.io website or go to ethereum.eth.link or any of those sorts of websites that are all IPFS enabled, and it'll load it directly over your local IPFS node. Or there's an experimental option within the extension settings where you can, instead of using a local IPFS node, so one that you're running locally on your machine, you can say run an embedded JS IPFS node. So if you don't have Ipfs Desktop, you can enable that setting and it'll instead spin up in JavaScript an IPFS node that can load content from the public network in that way. So common question, but if you have a more specific one, I'm happy to answer it.
So there is another question, which is, how can you make IPFS faster when it is not nearby or commonly accessed? So basically performance.
There's so many questions about performance. I'm not quite certain what this one in particular is asking about, but I can talk to you a little bit about the improvements we made in the most recent release in 0.5. Some of the major performance improvements there were, one, looking at all of the nodes joining the network. We have hundreds of thousands of nodes. Some of those are browser nodes, some of those are mobile nodes. A lot of those nodes are on local, just individuals in their houses that might be behind NATs and firewalls. And so one important step in this release was doing a kind of pruning where each node looks at their own connectivity and makes a judgment about whether or not they're going to be a good participant in our DHT, which is how distributed hash table, it's how everyone in the IPFS network routes requests for content. And so previously, everyone participated in the DHT, and you had to manually configure yourself if you wanted to, say, just be a client of the DHT and not actually participate in routing traffic. And now we do kind of a more dynamic assessment of, am I going to be a good participant in routing other people's requests and traffic? And if you're, say, behind a firewall and you won't be able to do that effectively, you don't take on that additional task, which helps make the network a lot faster, because instead of trying to dial a number of nodes, which you're not going to be able to connect to, you can be much more efficient in your query and how quickly you can go and find the data you're looking for. So that's one example of a way in which we've improved the find time within IPFS. Another area of improvement was we worked closely with groups who wanted to fetch content very quickly peer-to-peer. So an example here is the work we did with Netflix back in kind of August through October timeframe, where they had a container distribution challenge that they wanted to make much more efficient by using peer-to-peer data transfer. And we worked with them to actually measure, benchmark, and improve our peer-to-peer data transfer algorithm called BitSwap, in order to make it so that as you're spinning up a new machine to do as part of your build process, your CI/CD, you can very quickly fetch the exact pieces, the exact blocks of data that are needed in order to do that from all other nodes in the network. And so kind of the concept of IPFS, where like all nodes can directly send data to each other. You don't have to use some sort of central registry in order to fetch that, helped make things a lot more efficient. And we have a blog post I can drop in the chat about that if other people want to learn more, with lots of graphs. Everyone loves graphs.
Awesome. So next question. What is the relationship between IPFS, Foulcoin, and Protocol Labs?
So IPFS is an open source project. It was initially, I think it was actually created before Protocol Labs existed as a company by Juan Bonet. And it's now grown to be over 4,000 open source contributors across a whole ton of different companies and organizations. And Protocol Labs is an organization that funds a number of people who contribute to IPFS, but also a lot of other open source projects as well. So there's people who work on libp2p, people who work on SourceCred, which is a very cool kind of identifying how to do value distribution and kind of reward people for contributions to open source projects, and a number of other research projects as well. And so a number of people who work on IPFS are funded by Protocol Labs, but a very small number of the 4,000 open source contributors. And then Foulcoin is another project that was initially created by Protocol Labs, but also has a number of groups participating in it. And Foulcoin aims to be an incentive mechanism for people to store data long-term in the IPFS network. So right now, there's a number of groups who, say, run pinning services or otherwise participate by storing other people's data. So there's things like collaborative clusters or other community ways of kind of incentivizing other groups to store public good data. But if you want a fully distributed storage mechanism, then using something like Foulcoin, where there's a marketplace of people buying and selling storage, is a great way to get long-term persistence of data in IPFS. And so that's kind of the problem that they're aiming to solve.
Very cool. So I actually have a question for you. So I've actually never heard Web3 described as read, write, and trust web, but it's actually a perfect definition for it. Did you guys come up with that, or is it?
I'm definitely stealing this from a talk that Juan did at, I think it was Web3 2018 in Berlin, called What is Web3? I think that's what it was. And so I'm stealing his definition from there and his slide. So thank you, Juan, for letting me steal your slide.
Got it.
But it's a great example.
Cool. So you mentioned for Web3 and Web2, like you guys need to actually bridge it and get more people from Web2 into Web3. What have you seen in terms of like some success stories in terms of how people are able to migrate people into Web3?
Yeah, I mean, I think Fleek is an amazing success story where, they were able to see the benefit of using some, adapting the UI to make it very familiar and intuitive for anyone who's used to using Netlify or deploying a static site today using, Hugo or ViewPress or something along those lines, and to just really quickly get up and running with the kind of the frameworks you expect and are used to using, but that you're able to just deploy to the DWeb and get kind of that pervasive, that sense of coming into this space doesn't require knowing all of the internals and like taking courses in distributed systems. You can just use tooling that feels familiar to you. I think that's an amazing success story. I think they had thousands of people signed up within like the first month. So that's and by signed up, I mean like actually having gone through the process of deploying their own website to the DWeb, which is amazing. So I think that's a really cool exemplar of the sorts of tools and applications that are possible to build now. Because like a year ago, that would have been still quite hard. Like the infrastructure, the tooling to make that possible, that level of like polished UX was still kind of landing. But I think we're getting to a state with the infrastructure that's been built up in the Web3 space that new, like very seamless tools like that bridge people's expectations of how to work with the web are getting more and more possible. And so that's what I'm excited about.
Yeah, that's amazing. So in terms of people and their expectations, when you talk to companies in Web2 or developers in Web2, like what are some common things you've heard regarding like why they should actually use IPFS, or like what convinces them to actually migrate into Web3?
Great question. The things that I've heard the most are like they want to understand clearly what the benefit is. I know there's a lot of us in this Web3 community who are doing it because we're aligned around a mission that this is the way the web should work. And we do, decentralization for the sake of decentralization speaks to a lot of people in this community. But when you talk to Web2 companies or large organizations, they want to understand what is the problem this is solving. And so that's, what is the efficiency? What's the cost? What's the data? Like, where's my benefit from like a bottom line business perspective? And so working with organizations like Netflix, where you can clearly see, great, how many hours of developer time would it save to use IPFS versus using, Titus or Docker Hub, or working with an organization to think about, great, how much data am I storing? How much less data do I have to store if I can do content-based deduplication like I can with IPFS? Or how much more efficient would it be for me to seed data and have the whole network be able to distribute it more resiliently and more peer-to-peer? Again, getting to those bottom lines of where they get the real benefit. And that's really having the testing. It's having the metrics, which I think is something that's still, it's more nascent than I wish it were in the Web3 space, building up the tooling that demonstrates this is what the gain looks like. Yes, it's reliable. Here are all the test cases where you can see that benefit. Here are the graphs that show you what the cost differential will look like. And then building up that reliability as a service as well, that, great, there might be a performance improvement, but if, the network's falling over every other minute, then that's not that exciting for a group. And so also building up that reliability and stability as a service. So we built a lot of tooling actually as part of doing this recent release to both be able to demonstrate the performance gains we were having and be much more reliable about network performance and resiliency.
Yeah, that's fantastic. So if people actually want to contribute to IPFS, what's the best place for them to go?
We always love working with new contributors. Probably the best place to start would be, there's an IPFS Help page, which has a lot of great links. So if you just go to ipfs.io/help, that's a great place to get started. There's a lot of help wanted issues on GitHub. And so depending on whether you're a JS developer or a Go IPFS developer or a Rust developer, there is now a Rust IPFS implementation. You can get started on some of those help wanted issues. And I think the tag in every repo is always just help wanted. It's a big green button on any issue that wants some help. So that's a great place to go and start contributing. We have a discuss forum, discuss.ipfs.io, and that's a great place to talk to people who are excited about projects and maybe looking for other people to help them out or exchange ideas about something they're passionate about. And then finally, I'd point folks to, we have a new Dev Grants program. So both libp2p and IPFS and Foulcoin actually all have Dev Grants programs. So if you're excited about building a new piece of tooling or infrastructure or project within the space that's going to benefit the wider community and network, that's a great place as well to go and identify ways that you can help push things forward and also get funding to spend your time that way.
Awesome. This was a really fantastic talk. I'm really sorry the chat broke. It's working again now, though. But thanks so much. We're going to transition to our next session.
Awesome. Thank you so much for the great questions, and hope everyone has a great rest of the conference.